and welcome to Adapulse, the channel that brings you all the news and all the proposals that are in and around the Cardano ecosystem. Now, you might remember a little while ago, we did a video on Cardano's growth in 2021. This episode, we're looking at the forward to the Basho era, and that's scalability for Cardano in 2022. So this is an article by LIBERLION, and it's looking at the potential growth and all the problems that are being solved this year in Cardano. So I'm Josh from ATM, so let's dig right into it. Let's go. Cardano evolves through eras, and each of those eras has its own theme and its own name. So Byron was the foundation. You hear Byron when you're in Yoroi, for example. If you're activating a wallet, it'll ask you if it's a Byron wallet. So that's a reference to that era. Shelley is decentralization. So that's when all stake pools went live. So SPOs like me and many others were there for Shelley launch. And that represented that era. Goguen is smart contract programming. So that's the era we're in now. As you hear about Plutus, that's all smart contracts. Voltaire is governance, and Basho is scalability. Now, each era is like a new milestone in the development of Cardano. However, they are still kind of running at the same time. So they are all running in parallel, basically. So you don't need to completely finish one era to then start on to another. So they're always in constant progress and improvement. So this year, 2022, is the year of Basho. With the Alonzo hard fork and the enablement of programming in the Plutus language, it was possible to develop DApps for DeFi. Although with NFT airdrops, there were spikes in congestion, the significant and continuous increase in transactional traffic we began to notice it with the DEXes, that's MuesliSwap, SundaeSwap, and then ADAX as well. As major components, and that's including wallet connectors and the Plutus application backend, known as PAB, are finalised and integrated into the mainnet, further activity is anticipated. With current parameters, the Cardano network is using on average around 90% of its capacity. All of this demonstrates the need to improve network scalability, which means processing transactions faster and with lower latency and without increasing the cost. Part of the scalability is blockchain propagation, which is the time it takes for a newly minted block to be transmitted through the node's network. So in order for the blockchain to remain secure, the current protocol, Ouroboros Praeos, propagates a new block every 5 seconds. There is also something known as the block time budget, which is this fixed amount of time available to process all transactions included in a single block. This is divided between the time that can be used for the execution of the Plutus script and the time that is available to execute other transactions. Now, it's currently set to 1 second. For security reasons, the Praeos consensus protocol selects only a small fraction of the blocks, like 1 in 20, that could potentially be added to the chain. The current protocol parameters, the maximum transaction throughput for simple transactions, is approximately 11 transactions per second. TPS, so you might hear that a lot. TPS is transactions per second. By using a fixed size mempool, so that's a repository that stores transactions waiting to be processed, so a queue, if you will, the possibility of nodes being overloaded during times of high demand is actually avoided, but it does mean that a wallet or application may need to return to actually send their transaction. Now, the mempool size is currently set to twice the current block size. Ethereum is creating 80 kilobyte blocks every 13 seconds. So each block size is 80 kilobytes and they do it every 13 seconds. Cardano, 74 kilobyte blocks every 20 seconds. So we have around 3.7 megabyte moved onto the network for Ethereum and 2.1 for Cardano every 10 minutes. Now currently, due to Plutus's rather large transactions, Cardano's network efficiency is slightly lower than Ethereum's, but that is before Plutus's script optimizations are implemented. Basho. IOHK proposes a scalability plan. Now, an important feature of the Cardano protocol is that it's been designed with scalability in mind, and flexibility being key to this. Now, IOHK proposes gradual and methodical changes in the parameters and then to monitor the results in the network as the plan advances. So we'll go through them now. So first we have parameter adjustment. The first adjustment made recently was to increase the block size by 12.5% from 64 kilobyte to 72 kilobyte. So there are almost 3 million Cardano wallets in use and traffic has grown almost 20 times from less than 10,000 transactions a day like in November 2020 to almost 200,000 per day. So that's this year. So with larger blocks fitting more transactions will provide more capacity for users. Now the second adjustment made was the increase in Plutus script memory units per transactions to 11.25 million. So again, that was an increase of 12.5%. So it must be a lucky number or something. But this is a powerful change and DApp developers really getting their dicks hard. An increase in Plutus memory limits means that you can develop more sophisticated Plutus scripts, or your existing scripts can process more data items, increase concurrency, or expand your capabilities. Also, very recently, improvements to the central node software were implemented with the recent version of 1.33.0. So that's executed by stake pool operators for the consensus of the blockchain with new improvements. So I had to do it myself. And now blocks propagate faster and with less RAM requirements, about 1 gigabyte less. Due to two factors, memory compaction and more efficient memory sharing. So instead of multiple instances of the same object, now multiple threads within the system will use the same object. Later this year, more significant improvements to the node are promised, such as the pipeline. This technique will merge block validation and propagation. So instead of going through the process of getting a header, validating it, then getting its corresponding block, validating it, and then sending it to the peer, it will get a header, validate it, and send it to the peer without actually validating the block. This simplification will give the network even more room to make further changes. Pipelining will significantly increase the scope and headroom we have to make further improvements to the network by reducing block propagation overhead, also known as dead time. Now, next on the list are input endorsers. Now, input endorsers improve block propagation times and throughput by allowing transactions to be separated into pre-constructed blocks. This improves consistency of block propagation times and allows higher transaction rates. And then we have Plutus script improvements. Through smart contract optimization, even more effective use of the powerful EUTXO, so that's extended unspent transaction output. Yeah, even more use of the powerful EUTXO model will be achieved, which includes 3 Cardano improvement proposals, that's CIPs. One is reference entries, which is SIP31. Plutus scripts can inspect transaction inputs without spending them. So this means that it's not necessary to create UTXOs simply to inspect the information contained in an entry. 2. Plutus datums, which is SIP32. Data can be attached directly to outputs instead of data hashes. So this simplifies how the data is used. A user can see the actual data instead of having to supply the data that matches that given hash. We can go through hashes another time. And the last one is script sharing, so the reference is SIP33. Plutus script references can be associated with transaction outputs, meaning they can be written on-chain for later reuse. So it won't be necessary to provide a copy of the script with each transaction, so that reduces some of the friction that developers face. Now, reusing scripts across multiple transactions will significantly reduce the transaction size. So that not only increases the performance, but that also actually lowers the cost of the script execution. Now, according to estimates by some developers, with SIP33, that last one, and script compression, Plutus scripts can be reduced to about 2 kilobytes on average. 2 kilobytes. So, you know, you think of the limits that we're working with now to come down to 2 kilobytes, that's pretty crazy. And another thing is sidechains. Now, a sidechain is an independent blockchain connected to a main blockchain through a two-way mechanism, or like a bridge, if you will. So that allows tokens and other like assets, NFTs, whatever, from one chain to be used on another. Now, a single main chain can have multiple interoperable sidechains connected to it, which can operate, and they can operate in completely different ways. EVM sidechains coming to Cardano include DC Spark's Milka Media and IOG's Mamba. So we all want to see Charles's Mamba later in the year. And then we have Hydra.
And Hydra will rise from its ashes.
And no, not that Hydra. Hydra is the second layer solution. based on an EUTXO model that allows delegation space to be fragmented without the need to fragment the general ledger. It introduces isomorphic state channels to maximize performance, minimize latency, incurs little to no cost, and greatly reduce storage requirements. Hydra provides a more efficient means of processing off-chain transactions while using the main chain ledger as the secure settlement layer. Next on the list is off-chain computing. The offloading of some of the calculations, for example with asynchronous contract execution, as ACE, it can drive greater core network efficiency. Transactions occur outside of the blockchain itself, but can offer fast and cheap transactions through a trusted model. And then we have Mithril. Now, Mithril is the cryptographic construct that allows thin clients, that's such as non-node wallets, to obtain data from the blockchain without downloading all of its contents. Now, anyone who's used Daedalus knows what it is like to download the whole blockchain, because it's a full node wallet. You're basically running a node, essentially, with Daedalus. So that's what that is. Any SPO knows what it's like to download a whole blockchain. So synchronizing to the blockchain is an intensive operation because it's so large, has such a large information base. So it's something like 28 gigabytes and is constantly growing. The main problem is to extract only a certain part of the information from the network for a thin client, so they don't have to download the whole thing, basically. The cryptocurrency holders will include the Mithril keys along with their basic crypto keys. So this will all happen in the wallet, so probably not something you need to think about. The blockchain will contain all the information of the UTXOs, the information of the registered accounts, and the Mithril keys. At regular intervals, the full nodes will collect the UTXOs and test where they can produce a pre-signature. Now this test is essential, since not all holders are eligible to issue the signature on a given message. Only one set will be chosen at random, basically. Only when there is a sufficient number of pre-signature fragments, which are issued by those chosen, will it be possible to add said fragments to the final Sigma signature. This will improve chain synchronization while maintaining trust with multi-signature aggregation, which is a fast and efficient way of logging without compromising any security features. The Babbage hard fork. Now, input-output software engineer Kevin Hammond commented on Cardano's next steps, revealing that IOHK has a hard fork scheduled for February called Babbage. Now, this is named after the mathematician Charles Babbage, considered to be the father of computers. I guess Ada Lovelace was the mother of computers, and he's the father of computers. Just out of interest, check out this picture that I took literally last week. I was at the Science Museum, and I managed to catch a glimpse of Charles Babbage's difference engine. And I do believe he worked on Ada Lovelace to make the big version. But there it is. But the Babbage area comes with various performance improvements to the blockchain, which have been in the works for a considerable amount of time, and so performance issues will be addressed. The Plutus language will also be receiving a significant update. Now, the following changes are detailed on GitHub. So with the protocol, that's a single VRF check, removal of protocol params D and extra entropy, no overlay schedule, or OBFT. Now with the ledger, collateral return output, including the total collateral field, reference inputs, inline datums, reference scripts, and fix one or both reward calculation warts from the Shelley era. SPOs know all about those. Now, just to sum up, the difficult balance of growing in an orderly and efficient way is not foreign to Cardano. Scalability is critical for both growth and adoption. Being a permissionless network, independent developers are building their products without pause. They are just full steam ahead, with releases that we will see more and more frequently. And although this is desirable, it highlights the urgent need to reduce the transaction processing times in the blockchain system. With the scientific rigour that characterises Charles Hoskinson, for those who don't know, the co-founder of IOHK, and his team even, peer-reviewed and the large number of research papers that have been published, the measure twice but cut once philosophy is more than known to them. The planning that we have discussed in this article today only shows one thing, that 2022 will be the year of Basho, and that's one to look out for. And that's all, and that's us for today. So the full article can be found online, and I'll also include a link below. But thanks for joining us. Please do support the channel by liking, subscribing. You can hit the subscribe button that's appearing up there, actually, and leave a comment below. We do love to hear comments. We love to interact with you guys and know what you're thinking. And you can further support the channel by delegating your ADA to Swag, Zod, or ATM. And I'm Josh from ATM, and that's it for now, and I hope you join us next time. Thank you.